Hello everyone, this is the tutorial for the plating module of Gearotic Motion. As you can see, I have just loaded a clock project on the screen that I just happen to have in my folder. And on the project screen we now have selections for bearing ODs, and underneath each shaft will be written the bearing OD, which will be the size of the hole which is in any plates that you surround your object with. If we look at the bearing ODs, you'll see that they're defaulted at the moment to the same size as the shafts which hold your gears. This would rarely be the case unless you don't intend to use bearings in your plate, and I do recommend if you're going to build a clock that you put bearings in your plates. Right-clicking on the shaft name will give you a selection for Set Plate Bearing OD. You can see if I bring it up, I can simply enter a new OD for that bearing. And this means, in this case, that I want to set the bearing to 10 millimeters for this particular shaft. The system didn't accept the shaft change because we don't yet have plates. So let's add some plates. If we go to the Plating tab, you can see now you're presented with a front view of the clock that we have, and we can see that the case width, depth, and height are all set to 0. This would be the default selection, meaning that you don't have plates as yet. But a button at the top of the screen says Get from Project, and this gets the size of the clock from the project. You can see it listed now in the width, depth, and height. This relates to the maximum extents of all the gears that are in your mechanism. Once we hit Get from Project to set up a base size of our frame, we can now select with the plate selection which plates we want. I'm going to select the front plate, and you can see that a plate now appears. The plate now has holes in it, and if I grab the plate and move it aside, you can see the holes that are appearing in the plate. Every time I drop the plate, the holes are regenerated to match the plate that we have. Let's turn on some more. Let's turn on the back, and you can see I now have a front and a back plate. And we can turn on left, right, top, and bottom. Now here are plates which you could glue together or screw together if you're using metal. We quite frequently, if we're using a laser or wood, we might want tabbed plates to keep everything in check. So if I hit the tabbed button, you can see tabs appear, and if you cut these frames, they'll all fit together into a nice box. For those of you who do clocks, we have a clock faced button which gives us a rounded face. Now the idea here is to make your case wide enough, deep enough, and tall enough to contain your mechanism, in this case a clock. When you're on the plating screen, simply clicking on the screen allows you to shift your box around. The best way to do this is to select front, zoom the screen to a proper size, and then move the plates to the approximate spot that you want that clock to sit within your plates. If we then look at it from the left, we can see that we're way off of our gears, so we're going to set it, just wiggle it back and forth until it's on top. And we're probably a little tight because I don't allow clearances when we do this. So you can just go up to the depth box, and I'll enter a 45 here and hit return, and then regenerate. When I hit regenerate, the box is now wider, and we have a bit more flexibility in how we fit it. You can make that as wide as you want. For an example, let's do 55. Hit enter, and you can see that the box gets bigger. Now we simply center to our mechanism. We can look at it from the top and do the same thing to make sure that we're properly centered, and then again from the front. If there's any question how things are running, you might want to go to solid wire and just look at it as a wire object so that you can see your holes and how everything is matching up. Once that's done and everything seems to be centered the way you like it, go back to your project screen, and you can now see that your box is part of your project, and now we're free to set sizes. Such as shaft 1 where the pendulum is, we can right click and set the bearing on OD on that to say 15. The hole instantly changes to 15 on the screen. If I tilt it, you can see it. It's a little hard to see without tilting some of these because I've tried to keep the plates to quite a transparent level, but now you can see on the screen that we're going to have 15 millimeter holes for the bearing, and the shaft, hopefully its ID will be equal to the ID of the bearings. That's the idea. Okay, that's generally how you generate plates. Whenever you select the output manager, you don't even need to select a type of output. Simply hitting Create Output will now create the plates that you have. I'm going to load our front plate so that you can see this. And of course I use Vectric again. VCarve Pro tends to be my favorite program, so I'm just going to load it in that. You can see now we have a tabbed object with our round faceplate. If I bring up the left view, there's our left tabbed plate, which would fit into our front plate. All these items will fit together. Your shaft holes will be in the right location, and it's all automatically generated in addition to the compensated output in case you want to compensate for kerf. Of course, if you're cutting these out of wood or metal, you'll have to file or chisel out the corners to make nice square plates for the tabs. On the plating, by the way, the material thickness is highly related to these tabs, and there are times when some outputs will turn on or off depending on how you've done things. For example, if I turn off clock faced to give us a square box, I can then turn the top back on and the top will tab in. So you can see that now we have tabs all along. If I turn off any particular side, for example, if I turn this side off, you can see the tabs have disappeared. We'll end up with straight edges, and you won't have to put up with tabs where there is a side that you didn't intend to use. That's it for tabbing. At the moment it only puts out DXF, but very shortly it'll put out the G-code to cut these objects as well, so that you can create a good-looking frame to hold all your pieces while you experiment and build a working mechanism. Thanks for watching.